Hello and welcome to all students. In this lecture, we will learn about Euclidean space. Okay, and here we will discuss about the point uh, open ball in Rn. Okay, so open ball in Rn. What is open ball in Rn? We will learn here. So let us start. So first of all, we write the definition of open ball in Rn. Let A equal to A1, A2, An be any point in Rn and R greater than 0 be any real number. Then the open ball about point A with radius R is denoted by ball about is denoted by B of AR. B of A comma R means we read it as a open ball about A with radius R, and it is defined as open ball about A with radius R equal to it is the set of all those vectors in Rn which are within a distance R from point A, or we can read it as open ball about A with radius R. It is equal to it is the set of all vector x belongs to Rn such that norm of vector x minus a is strictly less than R. Okay, so this is the definition of open ball in Rn. Now here we note some points. First point is ball about A with radius R. We read it as open ball about point A with radius R, and open ball about A with radius R, it is the set of all those points in Rn which are within a distance R from point A. Here A is called the center and R is called the radius of an open ball about A with radius R. Let A be any point in R and R is greater than 0 be any real number. Then the we are discussing about the open ball in R. So let A be any point in R and R is greater than 0 be any real number. Then the open ball about A with radius R, by definition it is the set of real numbers which are all those real numbers which are within a distance R from point A, or we can read it as it is the set of all x belongs to R such that modulus of x minus a is strictly less than R. So if we consider this term only here, modulus of x minus a is strictly less than R, then by property of modulus we can write x minus a is greater than minus R and less than R, and if we add a plus a in each term, then you will get the this step. So this will imply a minus r is less than x and x is less than a plus r. Okay, so this implies open ball about a with radius r is the set of all those points in R which lies in open interval a minus r comma a plus r. Okay, thus the open balls in R are nothing but the open intervals in R. Therefore, open ball about A with radius R is equal to open interval A minus R comma A plus R. So we draw here open ball geometrically. We represent open ball in R. So open ball in R is nothing but the open intervals here. This open interval uh, about point A Okay, so this is the open interval, or we can say open ball about point A with radius r. Okay, so this is the open ball in R. Now we discuss about the open ball in R2. So let A equal to A1 comma A2 be any point in R2, and let R is greater than 0 be any real number. Then open ball in R2 is denoted by ball about A, open ball about A with radius R, and is defined as open ball about A with radius R equal to, it is the set of points in R2 which are within a distance r from point A1 comma A2, or we can read it as open ball about point A with radius r equal to, it is the set of all ordered pairs x comma y belongs to R2 such that the norm of vector x comma y minus norm of vector x comma y minus vector A1 comma A2 is strictly less than r, or we can say the distance between the vectors x comma y and the point A1 comma A2 is strictly less than r. Here consider this inequality, distance between, so this norm is nothing but the distance between these two vectors, vector x comma y and vector A1 comma A2. Okay, and the distance is strictly less than r. So if we simplify this thing, just simplify this thing, so take the subtraction of these two vectors and find the norm of subtraction of norm of this vector. Norm of this vector is square root of x minus a1 square plus y minus a2 square, and this is less than r. And if we take a square on both sides, you will get x minus a1 square plus y minus a2 square is strictly less than r square. But geometrically, what does it represent? That is very important. Okay, so therefore ball about A with radius r equal to, it is the set of all ordered pairs x comma y belongs to R2, such that x minus a1 square plus y minus a2 square, and it is less than r square. Okay, so thus open ball in R2 is nothing but the set of all points in the interior of circle x minus a1 square plus y minus a2 square is equal to r square. So from this discussion we conclude that the open balls in R2 are nothing but open balls in R2 are nothing but the open ball in R2 is nothing but the set of all interior points in the interior points of the circle with center A and radius r. Okay, so here boundary points are excluded. Boundary points of that circle are excluded, and all interior points of that circle forms a open ball about A with radius r. So we draw. So geometrically we represent the open ball in R2. Here we draw the x-axis, y-axis, and suppose A is origin, both are perpendicular, and suppose we draw the circle with center A and radius r. Okay, so this is the circle. Here we have drawn a dotted circle, means boundaries are excluded. Okay, boundaries are excluded here, and so we shade all the interior part of that circle. So the set of all interior points of that circle, these interior points forms an open ball. Okay, so this is open ball about A with radius r. Okay, so this is the open ball in R2. Now similarly we discuss about the open ball in R3. R3 means space of dimension 3. Let A equal to A1, A2, A3 be any point in R3 and R is greater than 0 be any real number. Then open ball in R3 is denoted by ball about A with radius R and is defined as open ball about A with radius R. It is the set of all ordered triples x, y, z belongs to R3 such that the distance of the vector or the norm of vector x, y, z minus a1, a2, a3 is strictly less than r, or we can say it is the set of all points in space which are within a distance r from point A. See here, within a distance r from point A. So we consider this inequality here. We consider this inequality here and we simplify this thing. Then what we get is, so this is the norm of subtraction of these two vectors, and this norm is strictly less than r, and this implies square root of x minus a1 square plus y minus a2 square plus z minus a3 square is strictly less than r. Squaring on both sides, we have this step, x minus a1 square plus y minus a2 square plus z minus a3 square is strictly less than r square, and this step geometrically represents the set of all points in the interior of sphere with radius r and center a1, a2, a3. Okay, so now so see here, open ball about point A with radius r. It is the set of all those points in space which are in the interior of sphere, x minus a1 square plus y minus a2 square plus z minus a3 square plus is equal to r2. This open ball in R3 is nothing but the set of all points in the interior of sphere. This sphere has center a1, a2, a3 and radius r. So all interior points in that sphere. Okay. So geometrically we represent the open ball in R3. We draw here the three-dimensional space, three-dimensional coordinate system, x, y, z axis, and let us draw a sphere about point A with radius r, and here we have drawn a sphere without boundaries, and we just shade all the points interior of that sphere like this, and the set of all points in the interior of this sphere forms a open ball about A with radius r in the three-dimensional space R3. Okay, so now here, so this is all about the open balls in R2 and R3. Let us we stop. Let us end our lecture here, and we stop. Thank you.